So let's see the first problem. In the previous, this is a very recent GATE question, GATE CSE 2024, right? So let's understand the question. S1 and S2 be two stacks. S1 has capacity of 4 elements. S2 has capacity of 2 elements. The maximum size of S1 is 4 and S2 is 2. S1 already has 4 elements, 100, 200, 300 and 400. Okay, where 400 is, top is pointing at 400. Right, like this diagram. S2 has only 2 elements, both are empty. S1 has 4 elements and they are all full. The stack is full with 100, 200, 300 and 400. Right. The question here is, only the following 3 operations are available. Okay, push to S2. I want to, the operation is push to S2. What is that operation? Pop the top element from S1 and push it on to S2. The meaning of this is pop the top element from S1. Okay, so let's maintain this stack S1. I have 100, 200, 300 and I had 400 on the stack. This is the maximum size. This was my top. Okay, now push to S2 means pop the top element from S1 and push it to the S2. If I do this once, if I run this function once, what will happen? My S2 will contain which element? 400. Why? 400 is the top element of the stack S1. Okay, so this 400 is deleted now. 400 gets deleted and this becomes my top element. This becomes my top element. Right. Next, see, push to S1. What is the next one? Push to S1. Push to S1, meaning pop the top element from S2 and push it back onto S1. Okay. So in that case, this 400 will again go and here we'll get 400 if we do that once. Generate output. Pop the top element of S1 and output to the user. Pop the top element from the and output to the user. Note that the pop operation is not allowed on an empty stack, and this already we know the general condition. The question here is, which of the following output sequences can be generated using the above operations? By using these two operations, which of the following operations can be generated? Right? So it's kind of a multi-select answer, MSQ. It's a multi-select question, MSQ. In GATE, we have MCQ, MSQ, multi-select questions, right? So let's do it reverse engineering. You understood there are two operations, push to S2, push to S1. Means take the top element from S2, insert into S2. Push to S1 means take the top element from S2, add it to S1. Okay. Generate output means pop the top element from S1. Now what will happen? Let's try to see this. Okay. So let's do reverse engineering, take one option, option by option. It says 100, 200, 400, 300. Is it possible? Okay, let us see that. I have stack 1 with elements 100, 200, 300 and 400. Okay, I want this 100, 200, 300, 400. Is this sequence possible using stack 2, which have only 2 elements? This is my S1. This is my S2. Okay, I want this output 100, 200, 400, 300. Can I produce this using these 3 operations is the question. Okay, if I want 100, it means I can pop out. I can always pop out the element. So first only if I do pop of 400, if I use the function generate output function, if I use, I get 400, then I get 300, then I get 200, then I get 100 here. Only that order I will get, but I can use this advantage of the other 2 functions, push to S2, push to S1. Let me insert this 400 here. Let me pop out this 400 from here, add it to this S2. Okay, using the first function. Okay, then can I take 300? I want output to be 100. Can I get 100 anyway? No way. I cannot get 100 anywhere, because if I even pop out 300 also and add it here, the stack S2 is full now. If I pop out the topmost element, I will get 200 only. I will not get 100 here in this context. Right? I cannot get 100 at any cost. because S2 has only two spaces. S2 has only two spaces. I cannot do that, right? So this option 1 is incorrect because we cannot get this output with these three operations. It is not at all possible. I cannot shift elements into S2 anymore. That is full already, right? So that is 1. Let's take the second one. So again, I will take this stack S1 as 100, 200, 300. This is the given input for us, and S2 is empty. Now, I want output to be 200, 300, 400 and 100. Can I generate this is the question. Can we generate this output after doing some certain operations? Let's see how to generate the answers for this, right? What operations can we do? See, I want 200 first. So one thing I can do, can you push this 400 onto the stack S2? Yes, I can push 400 here. This gets deleted because I want first answer to be 200. I want first answer to be 200. So I have taken by using push to S2 function, I am pushing this 400 to S2. Then again I will push this 300 to S2. 300 to S2. Now S2 is full. See, I want 200. Can I pop the top element here now? See, use this generate output function on S1. It will pop the element 200 and give you the answer as 200. We can get that. Next, I want 300. How can I get 300? Generate output of S2. Generate output of S2, you can get 300. Then you want 400. Generate output of S2, because once you use generate output, 300 is gone and it is printed. Now you use generate output again on S2, 400 is gone, I get that in my output, and then apply generate output function on S1, this 100 is gone and I get that output. See, we got this answer. So option B is true. Okay, let's verify other two options here. I hope the question is clear. It is said that we have to use only these three operations and check, can we generate the output in these sequences like this? If it is possible, which all sequences can be generated using these three operations is the question, right? So we found out that option B is valid. Now let's see the option C. It is 400, then 200, then 100 and 300. Let us see if we can do that. I will have 100, then 200, 300 and 400 in my stack S2, and in my stack S1. In my stack S2, it is empty initially. See, I want 400 first. Apply generate output, pop the top element of S1 and output to the user. This is gone, right? I can get that. I can get that top element from the I get output screen 400. Then next I want 200. What I can do, push to S2 logic. Push to S2 logic. Using that, this 300 can be shifted here. 300 can be shifted here. Now you write generate output function. So it will give me 200 because that is the topmost element. I'll get 200 here. Next I want 100. Apply again generate output function on S1. It will delete this topmost element 100 and give me as 100 there. Next you want 300. So before doing that, see, generate output function, it is popping the top element from S1 only. It means I have to shift back this 300 from S2 to S1 first here. I have to bring it like this. How can I bring an element from S2 to S1? By using push to S1, second function. By using the second function, I can bring that element from there to here, right? Now you can apply generate output. I can get the answer 300. So this sequence is also possible. So option B and option C are valid, right? Now let's verify the last one, whether the third one can we do it or not using the given data for us, right? So again, you will draw a stack here. You have 100, 200, 300 and 400. Okay. Then you have another stack S2 empty, S1. Right. The sequence given is 300, 200, 400 and 100. Can we generate this or not? If I want 300, I should first push this 400 onto S2. How? Using this first function, push to S2. So 400 is gone, 400 comes here. Now use generate output function. What it will do, it will pop the topmost element. Top is at 300. So I get 300 and this gets deleted. Next I want 200. Again pop the topmost element, I will get 200 here. Apply the generate output function, it will pop the topmost element of S1 and give you the output. Next I want 400. For that you have to use push to S1 function. Bring this 400 from S2 to S1 first. Then apply the generate output function. So this will delete 400 and give me 400 here. Then again apply generate output, it will delete this 100 and give me 100 like this, right? So if you see, three options are valid. Option B, C, D are valid operations on the stack. On this, for this given question, these three are satisfying. First one was not able, we were not able to satisfy. Why? Because I want 100. I want 100. It means the 100 should be my topmost element. For that, I should copy 3 elements, but in S2 I have only 2 spaces. I cannot do that, right? So answer is B, C, D here. Okay. So another latest question. It has little less thing to do with the stack, but kind of an evaluation of an expression. So I have included it here. Gets under the stack category. Okay, given an expression like this, we all know that when you have an expression like this, you evaluate based on the operator precedence, right? But they say here that the precedence is different. They changed the precedence of the operators, okay, and they changed the associativity also of the operators. Then evaluate it. So by default, you cannot simply say multiplication is having first priority, then is division, then plus. No, that will not work. They are overwriting the rules. Okay, they are overwriting the rules of the operators. They have defined a new operator precedence table. Based on these table, you have to find out the value of this expression. Okay, let's see what is. Let's evaluate the table. Plus has highest priority, minus has high. It means after plus, then is multiplication, that is medium, then is divided by, that is low. And the associative, you see, plus is from left, but remaining all three are from right associativity. Okay, so let's evaluate this expression step by step, right? I'll write it 3 plus 1 plus 5 into 2 by 7 plus 2 minus 4 minus 7 minus 6 by 2. Let's give brackets here. Okay, let us define some brackets first. See, among all these operators, plus, multiplication, division, minus, which is having highest priority? Plus is having highest priority, and that too from left associativity. It means this plus I have to do first. So first to find out 3 plus 1 value. Since it is left to right associativity, then the next plus is here. Do that one with 5. Sorry, do that one with 5. Okay, then where is the next plus? It is here, 7 plus 2. Do this one. Okay, that's it. We are done with the plus operators. Let's simplify the expression and write the modified one. So what will this become? Here 3 plus 1 is 4, 4 plus 5 is 9, right? So this is 9 into 2 by 9 minus 4 minus 7 minus 6 by 2, right? This one step is over. With the addition operation, the highest priority, we have completed it. Then the next one is subtraction operator. The next one is subtraction operation. It is having highest priority after plus, but it is from right direction. It means first you have to perform. Again, let me define brackets here. I will erase this lengthier one, right? This is done anyhow. Now define the brackets here. Okay, so first one, which is the rightmost left minus, you have to do this first, 7 minus 6, then do 4 minus this whole, then do 9 minus this whole. That's it. So how will the expression change? Now after this operation, it becomes 9 into 2 by, see, 7 minus 6 is 1, 4 minus 1 is 3, 9 minus 3 is 6. So it is 2 by 6 by 2. This is my leftover expression. Sorry, this is my leftover expression. Now, among these two, which one is having priority here? Which operator is having priority? Multiplication is having medium priority. That too from right. Anyhow, there is only one multiplication. So, this becomes 18 by 6 by 2. Now, the last one is division operator. It has the lowest priority. It is from right side. So, first to do this one. First to find out 6 by 2. Then find out 18 by this. Okay, find out 16. Then this 6 by 2 becomes 3. 8 by 3 becomes 6. Right? So, we get the answer as 6. So, the output of this expression is 6. Right? So, the operator presence table is changed. Accordingly, you answer the question. Again, may not be a stack question, but since there is evaluation of an arithmetic expression, we have come here. Let's see some questions on, see, the result evaluating the postfix expression. Okay, a postfix expression is given, find out what is the result. Here you have to use the stack. Here you have to use the concept of stack. It is GATE 2015 question. So let's evaluate that. We have seen today itself how to evaluate the postfix expression. So you have to create a stack. Whenever it's a number, insert onto the stack. So 10 is the number. Then came 5. Then came an operator plus. Apply that operator plus on these two numbers. So 10 plus 5, this becomes 15. So the top of the stack is 15. Then came 60, insert it as it is. Then came 6, insert it as it is. After this came division operator. How do you apply division operator? This is your V2, this is your V1. So it is V1 by V2, that is 60 by 6. So this result is 10. Store that back onto the top of the stack. So let me delete that and store here 10. Now came multiplication operator. Take the top two elements from the stack, that is 10 and 15. Actually it is 15 into 10. Okay, 15 into 10. Store this result back onto the stack. So we get here 150. Next you have 8. Push it onto the stack. Then you have minus. Minus means pop out again operator. Pop up the top two elements. So it is 150 minus 8, that is 142. Store it back on the stack. So this becomes 142. At the end you have to pop the element, that is 142. So answer is 142 for this question. Right? Very simple question. Postfix evaluation. Okay. Right. Let's see the next question. Yeah. Which of the following is essential for converting an infix expression to postfix efficiently? Infix to postfix, what is the logic we are doing? Suppose if I have a plus b into c minus d, if I have a logic like this, what we are trying to do? See, if it is an operand, we are pushing it to the output, no? We are pushing it to the postfix string. If it is an operator, we are inserting this operator onto the stack. Right? So what we have to use here, which of the following is essential for converting infix to postfix? If it is an operand, it means variable, push it to the directly add it to the output string. But if it is an operator, we are inserting that onto a stack. So which stack we need here? We need an operator stack, right? We need a operator stack here to do the operation. Okay, I hope it's a simple question again. It's maybe a long back old question on the stacks. Next, yeah, a recent question. Oh, but anyhow, it has some queue operations. So we will see this after discussing the queue concept of that. Let's come to the next one. Yes, yeah, we have an interesting question here. The following postfix expression with a single digit operands is evaluated using a stack. This is the postfix expression. Note that exponentiation is an operator. This is an operator. It is the exponential operator. It is like a power b. Okay. The top two elements of the stack after the first star is evaluated. What will be the top two elements of the stack after the first multiplication is evaluated? Let's evaluate this in sequence. Postfix evaluation. I will take a stack again here. The first element is 8, insert it. Then the next element is 2, insert it. Then the next element is 3, insert it. Then there is exponential operator. It means I have to pop out the two elements, right? So it is 2 power 3, that is 8. 2 power 3 means it is 8. Okay, 2 cube, indirectly it is 2 cube. So the next one was exponential. I am doing that operator and storing the result back on the stack, 8. Next came divide by. When the operator is divide by, what you have to do here? See, take the top 2 elements of the stack, that is remove this both 8 and 8, and you perform 8 by 8, the result is 1. Store that 1 onto the stack. Then there is 2, okay, insert it. Then there is 3, insert it. Then there is the first multiplication operator, multiply. See, they are asking the top 2 elements of the stack after the first multiplication is evaluated. So I will evaluate the multiplication on the top 2. What are the top 2 elements? 3 and 2. So pop them out, apply 3, again 2 into 3. The result is 6. Push this back to the stack. So my stack becomes 6 and 1. The question is the top 2 elements of the stack after first star is evaluated. It is 6 and 1. So answer is 6, 1. Right? So you see, there are so many questions based on this infix and postfix of the stacks. Right? Yeah. One more question on the stacks. Let us try to see this. Again, some code is given, but ultimately you see what they are asking. Output of the following program. There is an expression given. What is that expression? 5, 2, star, 3, 3, 2, plus, star, plus. A postfix expression is given. This code, this expression, we have to run this program. Okay, follow this approach. Maybe they have changed some algorithm here. Maybe they have changed some algorithm here, and they are asking what is the output of this particular code. Okay, let's do it step by step. So I have an expression with me which is a string, right? So again, what is defined here? Hash include is given, push and pop are defined, int main. It's again a C program, but let's evaluate. They have declared some variables here. See, while C equal to get char, while C equal to get char, not equal to end of file. It means until I reach the end of this string, until I reach the end of this string, what I have to do? If the first character is a digit, is that a digit? Push it to the stack. Okay, let's create a stack, push that to the stack, that is 5. Next, again, we will iterate it parallelly, we will do that code and also this. Again, there is a, I inserted it, 2 also over. Now, if the character is a plus or multiplication, if the character is a plus or multiplication, yes, we got multiplication, then m is equal to pop. So m will become 2, that because 2 is the top, then n is equal to pop, n becomes 5. So this is the top. Now r is equal to C is equal to plus ternary operator. If you remember ternary operator, right? Question mark and colon in C programming, right? So this is a condition here. What is the condition? Is C, if C, that operator is equal to plus, then you do n plus m. Otherwise do n into m. Otherwise perform n into m. So what is n into m? That is 5 into 2. That is 10. Push that into R. So 10 comes here. Again, this is the code we understood. It is postfix evaluation code. That's it. There is nothing much in this. So simply evaluate this expression and tell the answer. If you iterate, it's again the same thing, right? Then came 3, insert 3. Then came another 3, insert 3. Then came 2, insert 2. After that, we got plus. Next, we got plus. So take the top 2 and add it. This becomes 3 plus 2, 5. Again, we got multiplication, right? Multiplication is there. So multiply them. 5 into 3, it becomes 15. Then there is plus. So add these two, 10 plus 15, this is 25. So answer is 25 for this question, right? The final answer for this expression is 25. The logic was again implementing the postfix evaluation. It was the postfix evaluation logic. Okay, yeah. So this were again few set of questions on the previous gate questions on the stacks.